Thank you for coming. We are going to talk about serverless containers here today. Before we start talking about serverless containers, I want to show you this. This is what I look like when I wear a denim jacket. My name is Martin Omander, and I was born and raised in Sweden. I lived in Silicon Valley for these last 19 years. We'll let these people walk through. Please have a seat. All right. Lived in Silicon Valley these last 19 years. I worked at 3 startups as a software engineer and worked at Google for these last 13 years. And my current job at Google is that of a cloud developer advocate. So what that means is that, one, I'm out here and talking to you, great developers, about what Google has to offer you. And two, I listen to feedback from you because I meet the people who are building the Google Cloud Platform. I meet with them every week, and they keep asking me, Martin, what are developers asking for out there? Please tell us. And I tell them, for me to be able to tell them, I need you to tell me what you need. What is working well in Google Cloud for you? What is not working well? What is stopping you from adopting Google Cloud? So there will be a survey later about this, or you can just look for me. I'll be around all day. Look for the person in the pink shirt. Today we're talking about pet theory. So this is a chain of pet clinics that was started 12 years ago by Lily. She's a veterinarian. If you've never heard of pet theory or never visited one, that is because I totally made this company up. But Lily, when she created this, she has 2 main values for pet theory. One is to have an environmentally friendly clinic, and 2 is to listen to both the patients, those are the pets, and to their clients, those are the humans. So with this mission statement, and by hiring some amazing veterinarians, she has expanded and opened a 2nd clinic, and a 3rd, and a 4th, and now there are actually 34 of these clinics all over the country. They're doing very well, lots and lots of clients. They have helped lots and lots of patients, pets, to become healthier. When you have a company that goes from very small to very big in a short amount of time, you will run into some IT growing pains. So you will have customers who are annoyed that they can't get through. They want to make appointments online. You have people who are actually working, employees, who are saying they can't do their job for various reasons. Here you have an overworked poor receptionist who's supposed to send out invoices and wasn't able to do that because the phone was ringing all the time because people wanted to make appointments. And you have, oh gosh, you people, come on, go, yes. All right, so you have an appointment system, an old on-prem system that is down. We should really close that door. Some real IT growing pains. And this is what you heard in the keynote here. You've heard about how every company is pretty much a technology company. Lily, she thought she was running a veterinary clinic and treating sick animals was the core of her business. It turns out that she really needs IT to work well as well. Pet Theory is actually a software company as well, and the software just has to work. So she hires Ruby as a consultant to come in and help her to get this IT situation under control. It's not working. So Ruby and Lily and Patrick, the IT guy, they sit down and write a list of what they need to have working better. So first of all, they need to put all this pet data and patient data up online, rather than have it in some old clunky on-prem system. Second, they need to let clients make appointments, view and make appointments online. They need to automate the sending of the invoices. Remember, poor Lisa, she doesn't have time to send those invoices. And finally, they need to open up so insurance companies, calendar apps, and so on can go in and view appointment data, view pet data. So they need to open up to the world around them. This is pretty much important things that you need to do, most businesses need to do when they move to the cloud. Some variant of these 4 things. However, as Ruby and Patrick sit down, they pretty soon realize that there are 2 ways to build modern apps in the cloud. And this is a difficult situation. This is a difficult choice. On the one hand, you have the container way of doing things. On the other hand, you have the serverless way. That is like platform as a service, function as a service. Who here has worked with containers? Whoa, wow, a lot of you. Who here has worked with serverless? Also a lot of, whoa, amazing crowd. This is great. So those of you who worked with containers, you know that they're very flexible, you get great fine-grained control. You know that there's also a lot of work with containers and setup and maintenance. You also pay for stuff that you're not using. You have to provision ahead of time. Serverless is great because there's none of that setup, very little of that setup work. And you only pay for usage, but on the other hand, you're sort of locked in. Your app is not easily portable, and you can't run whatever you want up there. So this is tough. What if, Patrick asks, what if we pick the wrong path here? Will that path just end and we won't be able to go on? Fortunately, Ruby has read up on this, and she's seen the latest trend in cloud computing. And that is that these 2 paths are starting to merge. And that is what we'll talk about today. Serverless and containers are coming together. So no longer will we have to choose between the advantages of one or disadvantages of the other. We can actually have the advantages of both. So the product that does this in the Google Cloud Platform is called Cloud Run. Has anybody here used Cloud Run or played with it? A few, okay, 1, 2, yeah, okay, not many, okay, great. Looks great on paper, right? Of course it does. The marketing material says Cloud Run is great. Let's take it for a spin. So the first one is, let's just move this data up into the cloud. So to try this out, we have a service that's not customer-facing. Ruby writes this to import data. Let's see how it works. So here's the Cloud Console. If you've used Google Cloud, you may be familiar with this. This is cloud storage. This is file storage in the cloud. And in here we have buckets. They're analogous to directories. So let's just upload a file here of test data. Or actually, let's take a quick look, see what test data looks like. This is the test data file up here, customer ID, and so on. And here are various customers and their pets and their phone numbers. This has about 20,000 records in it. So let's upload that and import it into the cloud database. Test data is there. It's about megabyte. 20,000 records. It is now churning through this record by record, parsing the file, putting it in the Firestore database. Let's see here. It is still there. We can actually have a look at the log here. Writing 19,999 records to the database. Oh, I was short 1 record. And done writing to the database, and then it's deleting this CSV file. And if we go back to storage and CSV import, we see now that the file is gone. So it has imported these records into the cloud database. This is a Firestore database. If we go in here to Firestore, we'll see that in the pets collection, a collection is kind of like a table. We see that out here, we have the actual records, like Carolyn, she has a gerbil named Mary. Oh, that's a good name for a gerbil. Loretta, the reptile, and so on. So how did Ruby build this import job? Well, Let's do this. So the CSV file, she managed to convince the legacy system to create a CSV file. That CSV file, you saw how we uploaded it into cloud storage. That in turn generated a PubSub notification. And PubSub is sort of what binds the whole Google Cloud together, and it allows you to trigger jobs and have jobs talk to each other. That triggered her ETL job. ETL stands for, let's see, extract, yes, thank you. Extract, transformation, load. Thank you, I always forget. So this job basically takes the CSV and puts it in the database, which is Cloud Firestore. Let's have a look at the Cloud Run piece of this. So Cloud Run, each Cloud Run service is a black box where you can, as developers, can put anything you want in it. You just have to remember two things. Well, actually, three things. Your code must listen on an HTTP port. So you need to actually have an HTTP library as part of your code. And it must be stateless. Now, any code, it can't be purely stateless. Any system as a whole must have some state in it, like database records or machine learning models. But that does not live in the container itself. That lives in all these other products that are in the cloud platform, where the databases, file storage, machine learning is. Also, because this runs on Google Cloud, it is, of course, backed up and sits on top of all this error reporting and monitoring and debugging that you get for free with any product in the Google Cloud. Now, when Ruby writes this, she notices that her code here, index.js, this is her, she's writing this in JavaScript. Her file is like 50 lines of code. That's just a very small part of the total application. Any application, this application that she wrote, any application that you were writing, has lots of other pieces to it, various libraries to parse CSVs, integrate with databases, and so on. And this is traditionally, of course, you know how this works. When you deploy just the yellow piece here, and you don't have all the right versions in production of these various libraries, or you don't have them at all, you run into trouble. And your little 50-line piece of code won't run. So the solution to this, of course, is in the old school, old way of doing things, we would deploy just index.js and hope that we had the right libraries in production. I've been there. I've done that many times, failed many times. The modern way of doing this, of course, is with a container. You package all of this up in one container. So now it's safe to deploy this to the cloud, because you get the exact version of everything you're looking for. And the way you do this in Cloud Run is that you create a Docker file. Here in the Docker file, the important thing here is here you see it runs npm install, and then it runs npm start. npm install, that is Node's way of saying, run this package.js file, install the dependencies I have. And here you have all the dependencies and versions of the libraries. In Python, you use requirements.txt. In Go, you use something else. But this, by deploying this Docker file and this package.json file, that is how the whole environment is built up on the server. So the actual code would be, this is JavaScript, so the Express library is a good way of doing this. It's easy to fire up a service and listen to a port, even though Patrick has some doubts about server-side JavaScript. There used to be doubts about server-side JavaScript, but I think Node has proven itself. Then, of course, to listen to these PubSub notifications, you listen to a post coming in. And then Ruby's code checks that this is object finalized, is the event type that comes in. Event type is object finalized. Object finalized means the file is finalized. It has finished uploading. And then she needs to decode the JSON that comes in, and then she calls her own function, import file, that actually reads the file, calls the CSV parsing library, writes to Firestore, and then returning status 204. 204? What HTTP status is that? 200, we've heard of 200. Does anybody know what 204 means? No content. Thank you. Wow. Did you look it up or did you know? You knew it? Excellent. Yeah, so it basically says, this is okay, but I'm not going to give you any content back. There's nothing to return here, but 204 is good. All right, so now we've seen the CSV file going into file storage, PubSub, triggering the ETL job. We've seen how that worked. It's gone into Firestore. Now let's look at clients making appointments online. And demo time again. So the client would look at something that looks kind of like this. We'll just arrange the windows here a little bit. Here we go. So over here on the left, we see Carolyn McKissick. She's looking at her pet theory, the customer portal. So her pet's name is Mary. Was it, what species was Mary again? Does anybody remember? Gerbil, thank you. Yes, that was it. Mary is a gerbil. Okay, she can see there's no next appointment. Here is the administrator. This is Lisa sitting and checking the administration here. She can accept or confirm appointments and see various data on Mary the gerbil. Okay, so Carolyn wants to make an appointment. So let's see, what available do we have? Monday, as soon as possible. Let's do it on Monday. So she requests, and you see, because it's Firebase, you see here that the web front end here for Lisa, the receptionist, is updated in real time. And Lisa can now go in and click confirm. It's confirmed, and you see that in real time without any page reloads or anything like that. Carolyn's UI was updated. So this happens through the magic of Firebase. Firebase is a completely serverless database that does NoSQL, runs NoSQL, and it has, instead of tables and rows, it has collections and documents. Let's have a look at what that actually looks like in the code. So here, this is the customer view, .js. This runs in the client's browser. It does doc on snapshot. So it first looks at finds the right document. It's in the pets collection, and it has the customer ID. Then it does doc on snapshot, pulls out the data in that doc, and then it can update the user interface. So the magic that happens here is that doc on snapshot runs every time that the database is updated, meaning that you just need to declare that once, and everybody's UI stays in sync with each other. This means that not only is Firestore less administration because it's serverless, it is also less code to write, because you wouldn't need to write any server-side code here, right, to handle a REST API or something like that. The client connects directly to the server. Well, Patrick, he has some doubts about Firestore, because he goes in here and looks at the Firestore admin user interface, and he sees that, look, there are no knobs, there's nothing I can tweak, nothing I can change. Where do I go and check indexes? Where do I go and check for if there's been a corruption issue? Where do I set up my agent jobs? Where do I set up my disaster recovery? There's nothing I can't do that. Patrick doesn't like this. However, Ruby points out that all those things that Patrick just described, they are undifferentiated heavy lifting. What that means is that every company needs to do it, and it's pretty hard to do it right. But because every company needs to do it, let's just have some other company do it for everybody. In this case, Google. Google takes care of the disaster recovery and all the replication and OS config and all that stuff, making it very easy for whoever's using Firestore. All right, good. 2 down, 2 to go. We're halfway there. Ruby is feeling good about this. All right, so this is, we were going on with, number 3, automate the sending of the invoices. So Patrick points out that our on-prem system, it generates docx invoices. Lisa would then sit and convert them manually to PDFs that we could send out to people. Now, we need to automate this. Patrick is pretty excited. He has found a script that can convert docx files to PDFs. Let's take it for a spin. Let's see what it does. Now, this script brings some pause to Ruby. What is this script doing? Does anybody know? It is running some command line stuff here. It is calling LibreOffice. So, okay, LibreOffice must be installed on this machine. And it runs it on the command line in headless mode and converts to PDF. Runs like a sub process, opens, communicates with that process. This looks a little entangled. So LibreOffice needs to be on the machine, which means that OpenJDK must be on the machine, which means that, and et cetera, and et cetera. You need all these huge libraries. Now, Patrick, he is from an IT support background. He's like, do you have a problem with that? I just installed it on the machine. So Ruby does not know, it's not sure about how to get this working in the cloud. You can't just go and install LibreOffice on a machine. Except you can, because she has a new tool at her disposal. She has containers. And you can put, just like you can put a cloud storage library in a container, you can put LibreOffice in there. So the Docker file would look something like this. Here she's doing pip install to install some Python libraries like Flask and gunicorn, that's a web server. And here she runs apt-get install LibreOffice. So LibreOffice will then have other dependencies, which will have other dependencies, and this will run for about 2 minutes. But it will create a Docker image that is easy to deploy to the cloud. All right, they don't really know what this code does. They deploy it. Let's see what happens. It's running, takes a long, internal server error. Oh no, it was too good to be true. Okay, let's see how to deal with this. There is something here called the debugger, which I really like, and I don't have permissions to view. That's interesting. Let's just do a quick reload here. Sometimes gets confused about which account I want to be in. All right, cool. So here is the code, the Python code. You see it imports Flask, subprocess. Here is the code we looked at before, where it actually kicks off a LibreOffice job. Okay, so something went wrong. Let's have a quick look in the log here. Everything ends up in this log. Okay, so here we see a 500 error. And here's some trace back. Okay, we'll see, oh my gosh, that's a big error message. Let's just look at the last part of it. Value error, cannot determine path without bucket name. So there's something to do with buckets and directories and so on. Is this code that we don't know much about because we just found it online? So let's see. Let's see, something going on with buckets here, out bucket name. Okay, probably breaking somewhere around here. Let's just do this. We'll put a snapshot there. We'll run the service again. We'll get the error again. And let's just reload this to make sure everything is on the up and up. Here we go. We put the snapshot here, waiting for the snapshot. Waiting for the snapshot to hit. All right, this is the part where we should have seen an awesome cloud debugger pop up. Oops. So this is what it would have looked like. Don't know, maybe something with the Wi-Fi. This is a cloud debugger that works just like your local debugger. You can put you can put breakpoints in production and then see the values of your variables. And if you look through here, they would then see that there's out bucket name is not set to anything. They can go in and it turns out it's set by an environment variable. You can set that environment variable, run it again, and it works. So this has actually been very useful to me personally, because when I've deployed stuff and it has broken in production, you know how it is, right? It works great in testing, works great on the developer's workstation, works great in staging, breaks in production. And you can't reproduce the error locally, but you can reproduce it in production. Then you just put a breakpoint in production and you see what broke. All right, so 3 done, 3 out of 4 done. Open pet data to insurance companies and calendar syncing apps. That's the next part. So what Ruby decides to do here is to create a REST API. She builds a simple REST gateway in Cloud Run. Now this is a little different. Before we saw sort of back-end jobs doing their thing in the background. This is actually a Cloud Run job that faces the outside world. And because of that, we have some special considerations. Oh, lost mic. Lost mic. Does anybody know how to turn the mic back on? Oh, hand mic. Hand mic time. Let's do that. Hand mic time. Hand mic. Hand mic. Hand mic. I'll double fist it. All right. Now I have 3 mics. Hopefully one of them works. Or? No? All right. Two mics, 3 mics, yeah, that'll be a little too much. I'll go on like this, hopefully we'll get it working. So she decides to build a REST gateway, yay! A REST gateway, this is a little different. It's not a back-end job. This is actually facing the public internet. And as such, there's some special considerations. Well, she just puts it in a container. This is old hat, we know how to do this. Here, she uses the Express library. So this is very cool because you can do app.get, app.post, app.put, app.patch. What HTTP verb am I missing? Options, yeah, app.options, or delete, yes, exactly. So you can just implement those verbs. Here is an implementation of reading from Firestore and returning value as JSON. So it would just look like this. OK, great. So this worked. Let's see, reload. Oh, it was fast. Let's see if we can gauge how it's so fast. It's hard to tell how long it takes. And if we enter an ID that does not exist, we get a failure message. OK, great. Now, Patrick, he has some special concerns here. He's heard that scaling up and cold starts can be a problem on serverless. Because if you go from you have no load at all on the system, and then you start getting a lot of load, then Google, or whoever your cloud provider is, Google, or whoever your cloud provider is, when traffic scales up, they need to spin up more and more containers. So you'll hit all these cold starts. Cold starts are when your container starts running and for the very first time. It takes longer then. This is bad when we scale up. So let's run a test case, a worst case scenario here. You can run this on your own service. There are a bunch of great tools out there. So the team, they decides to run a 600 requests per second. Hopefully there won't be more hits than that on their system. 1 minute ramp-up time, 3 minutes of running 600 requests per second, 1 minute ramp down time. All right, what did they find? Well, first off, the bad news. There were 85 cold starts in here. These cold starts, this took about 6.8 seconds on average. This is not a good response time if we have a user waiting. The good news is that 99.94% of the requests were actually warm starts. They were running containers that have already been loaded into memory. And those saw some pretty good response times. Median response time was 49 milliseconds. P99, that is 99% of the responses were done within 120 milliseconds. So how do we think about this? Is this good? Is this bad? Well, first of all, it's great that you can write a service. There was no code modifications. Ruby just had her JavaScript code here and was able to handle 600 requests per second with no additional engineering work. This would take a lot of engineering work if you were not doing serverless. Then, of course, the question is, OK, what's acceptable for this business? What should our P99 value be? And when you go and ask your stakeholders, you will get this answer: they don't know. So you will need to sit down with them and discuss this and educate them a bit and talk about, is it P99 we're shooting for? Did I lose Mike again? All right. Is it the P99 value we're shooting for? Or is it the P95 value? What is acceptable? It's kind of hard to know if you don't have the number. You will have to sit down and talk with them. The team sits down, discusses this. They say, this is good enough. 99% of our users coming in under 120 milliseconds. Good enough. Let's do it. All right, we're all done. Now, Lily is very happy about this. She has heard, however, that that this cloud computing thing, is it really green? Is it environmentally sustainable? We've seen these big data centers. They draw huge amounts of electricity. Well, it turns out that, ooh, I'm back again. It turns out that every few years, Greenpeace issues a report called Clicking Clean, who's winning the race to build a green internet. And Google actually, last time they gave out this report, got an A, very happy about that. And they say, Google continues to set the bar for clean energy advocacy. And Google is actually the only major cloud platform provider that got an A in this. And the reason is, if you look at, this is data from Bloomberg, this is not Google's data, you see that Google at the top there spends far more on clean energy than any of the other cloud providers. So, looks like cloud computing is green, good to go. Of course, Ruby is happy that Lily is happy, because that means that Ruby will get paid on this consulting gig. Everybody is good with this, except Patrick. Patrick would like to point out that there's one issue that I've skirted in this whole talk and avoided. This is, after all, a talk about a veterinary clinic. And I have not mentioned even once the question of what is better, cats or dogs? This is where you come in. You're going to help me. Please go to pet-theory.web.app, and you will be able to vote. Cats or dogs, which is best? And you'll see take a look at the statistics in a minute. Also, from that survey, you will also see this bit.ly link. I would love for each and every one of you to go in and submit the survey. And in 5 minutes, we will have a drawing. And 2 of you will exit this room with a flick button each. Flick button connects to your phone. You click the button, and you can program your phone to do anything. It can send you like a fake phone call. So you can click it and like, oh, sorry, somebody's calling me, and you, very useful. It can send an SMS message with your location. It can even make an HTTP post or hit one of your services online. Very cool toy to use together with your phone. As you're filling out these 2 things, as you're voting, is the voting app working? It is? Okay, who's winning, cats or dogs? Dogs? Okay, is it a wide margin? Oh my gosh, that's a huge margin. All right, I better go in and vote for cats a few times. As you're voting and as you're filling out the survey, we'll have a few minutes for questions. And then in about 5 minutes, we'll have the big drawing for who walks away with the prizes. Any questions?
What is Patrick's
yes.
new job?
What is Patrick's new job? Oh, excellent question. Excellent question, yes. Well, it's interesting. A few years ago, people were talking about serverless being no ops. And we started realizing that nothing is ever no ops. We now call it low ops, which means that Patrick will still be there. He'll be, however, doing things higher up the stack. He won't check the database for corruption because Google takes care of that. But he will, he could, for example, build great apps, voting for cats or dogs, doing great customer engagement stuff, or being higher up the stack. Good question. There was a question back here.
Yeah, so two related, you can take either one. One, the blunt question, Google Cloud versus AWS. Love to hear your perspective. And if you're going to do that one, I'd like to hear more about this debugger, because I'm not familiar with a comparable service in AWS. And then the second question is just multi-cloud versus, should I do multi-cloud or should I do one cloud, like trade-offs there?
Oh, great questions. Yeah, so first off with AWS, I haven't actually used AWS much, and not enough to be able to make good comparisons, so I'm sorry, I don't know. Debugger, AWS side, I simply don't know. Multi-cloud or single cloud? Okay, so here's what I'm seeing companies do. Medium-sized companies and small companies, single cloud, because learning a cloud is, you have to build up expertise, a center of excellence within your organization. And that is hard to do in multiple clouds if you're medium-sized or small organization. Large organizations, multi-cloud. That's what I've seen people do, yeah. Does the cloud debugger have any features for masking sensitive information? I don't know. It's a good question. There is an API called, I forget what it's called now. There is an API, though, for clean logs and things like that of sensitive information. It looks like masks everything that looks like a name or phone number, things like that. I don't know about the debugger. Good question. I will look it up. Blue shirt, yeah.
Does the app stop working, or does it still function and then it runs 500 error?
With the debugger? Yeah, the debugger, it looks like a breakpoint, but it actually isn't a breakpoint. They call it a snapshot. So it just takes a snapshot of the values of all variables and a snapshot of the call stack at that point. The code keeps running.
You cannot step through. It's just showing the variables that have.
Yep, that's right. You can put many snapshots in. You can also have snapshots that are conditional. So only take a snapshot if this variable is empty, for example. So it feels very much like a regular debugger, except you're not slowing down or stopping production. Yes?
And just to follow up on that, is there a way to conditionally only do snapshots for like a particular request?
Oh, yeah.
It's like you might not want to debug 500 other requests and only debug yours.
Yeah, you would. Is there a way to only do certain requests? I think you would do some sort of conditional snapshot for that. It depends a little bit on exactly what you're doing, but I think that would be what you need to do. Yeah.
When you uploaded the Node.js code, what did you do? Just upload the JS file and the Docker file?
Yeah, how do you deploy stuff? Actually, I didn't show this. So what you do is first you run a command line to, can actually look at it here. Do we have it here? Yeah, so this one here, you run the Cloud Builder. This is, and you submit to the Cloud Builder, and that kicks off a build job in the cloud. In Google Cloud Platform has a build product in it. That generates a container. Now we have a whole list of all of our containers, of all the different versions of all the containers, and then we can either go in and click on one and say deploy it, or we can run cloud beta run deploy and the name of that container image. So it's a two-step process. Build the container, and then you have a whole list of containers, decide which container to deploy.
Where is it ingesting the code, though? Is this
The top, yeah.
that's like a push?
Yeah, that sends packages up, all the packages and everything you have on your local machine, sends it up, and it builds the Docker file on the server.
Okay. And do you have a folder structure for PDFgen that's recommended?
You would use nothing that's recommended. Well, I guess whatever works well locally for the local developer.
So it's just a Node.js project?
Yep.
Whatever hierarchy under
Exactly.
the Docker file in the root?
Yes, exactly. So because you want to run it and test it locally, so you use whatever works for you locally, and it can package it up. All right, I think it is time for us to find out who the winners are. Nope, that's not the one. Here we go. Link to Google spreadsheet. Everybody's using a Wi-Fi. Everything is slow. All right. 130 names added. Excellent. All right. If you haven't submitted the survey yet, I will give you another 10 seconds. It will appear here automatically, and then we will do the spin. All right. Time for the first one. The way this wheel works is it may look like I'm clicking it to make it spin, but what actually makes it work is drum rolls. So I would like all of you to take your left hand, right hand, and on your knees, and a drum roll, please. Who's going to be the winner? The first winner is HH, Roman. Roman B, where are you? Yay, there we are, Roman. Thank you for filling out the survey. All right, we still have one to go. Another drum roll, please. Who will it be? Christos? Oh, Christos! There we go! Yay! Christos! Thank you for filling out the survey. Thank you for coming and for giving me your attention. I will be around all day. Look for the pink shirt. Thank you very much.